Now we have this as third revision lecture, and we are with problems that is fixed beam. So for the fixed beam shown in figure, show the moment equation for segment CB. So segment CB means for this portion from left hand support. So we have, if we will draw free body diagram from left, then we will have this as, so I will keep this as fixed because we have to write equation from left. Then we have this will be VA. Then we have this HA, which will not of any use. It is going to be 0 as we do not have any load in horizontal direction. Then we have this will be MA. And then we have this force that is 200 kilonewton. We have this as 4 meters. We have this as 4 meters. So this is CB, and we are interested to write the moment equation for CB. So now we will make X in CB region. So we have let X will be here, and that is from C. So we have this will be X. And then we are interested to write the moment equation only. So we will write the equation that is moment equation. So we have EI d2y by dx square, which is equal to bending moment, equal to m, and that is equal to, now due to x, we are going to be this distance, that is x plus 4. So we have this is VA into x plus 4 clockwise, so plus. Then we have MA, this is also clockwise, so we have plus MA, we need not require to multiply by any distance because itself is moment. And then we have due to 200, this distance is x, but is anti-clockwise, so minus 200 into x. This is moment equation. Now what may happen? So someone may consider that whatever value of MA that is not essential clockwise. So you can have another choice. You can consider it anti-clockwise because we should not confuse why we have taken this MA as clockwise. So that is my choice. We do not know the values, and we are also not interested to calculate values. So let us, we will consider this MA that is anti-clockwise. So you have to go in examination one of the two. Do not go for both values. Only you should not confused with this why we have taken this value in clockwise direction. Therefore, I am showing this. You can have this or you can have this. So what I will get? So I can write EI d2y by dx square. And now it becomes equal to, we have M, and that is equal to, we have VA into, now same distance, x plus 4. Now MA, we have minus MA, and then we have minus 200 into x. Because distances are going to be same, we have this distance again same, x plus 4 till xx. MA need not require any distance, and then we can have this one. So this or this, you have to write in examination. If we have question, you have to write this equation or you have to write this equation. So this is one question which is from fixed beam, and then we have another question that is from fixed beam, and here show the equations of redundants. So now we have to go step 1. So we have static indeterminacy, static indeterminacy. Then we have ds E equal to, now R minus equilibrium equations, and we have R4 minus 2, that is equal to 2, neglecting axial deformation, neglecting axial forces. And as we are neglecting axial forces and horizontal equilibrium equation, Horizontal, because as horizontal forces are not considered, so you have to also neglect horizontal equilibrium equation, and therefore we have two equations only, that is fx0 and sorry fy0 and moment 0. dsi we have 0, and therefore dse we have 2 plus 0 2, and therefore beam is statically indeterminate to degree 2. Statically indeterminate to degree 2. To degree 2. In an exam, you need not require to go so much lengthy. It is sufficient. We have ds that is equal to 2. Then we have step 2. Now we have to consider redundant. Selection of redundants. Selection of redundants. And we have to consider these redundants, that is of left support or right support, and we will consider VA and MA as redundants. As redundants. And then we will go for the equations. So now we will have this, that is beam now becomes, if I will plot it, then we can have, I will keep this as fixed. Then we have this as VA. Now always we will consider a redundant plus, so we have MA. We have 20 kilonewton per meter and 6 meter. So we have this 20 kilonewton per meter. So 20 kilonewton per meter. And then we have this as 6 meters. So now we will go with table. So I will prepare the table. So we have serial number. Then we have region. We have only one region, but we have two redundant, so we have to go for the table. Region, origin, limit. Then we have M. Then we have dabba M by dabba VA. And then dabba M by dabba MA. So region we have one only. So if I will consider X over here, then we have serial number 1. A region we have AB. Origin A, limit we have 0 to 6. M we have VA into X. Then we have plus MA minus 20x square by 2. Dabba M by dabba VA is X, and dabba M by dabba MA is 1. So we will have this table, and now we will go dabba U by dabba VA, and that is equal to 0, equal to, we have 0 to 6 in bracket VA into X plus MA. Now I will make it as minus 10x square into X into dx upon EI, and that is 0. Now we will make it separate. So we are going to get VA integration 0 to 6 x square into dx plus MA again constant, we will take outside 0 to 6. We have x into dx, 10x square I will directly take right side. So we have 0 to 6, 10x cube into dx upon EI. And if we will solve this, so we will have first, that is integration x square, and that is from 0 to 6. We will have this value 72. So we have 72 VA plus we have value, that is integration x 0 to 6, and we will have this as plus 18 ma, and that is equal to, we have integration 10 x cube comma 0 comma 6, and we have this value 3240. So this is equation 1. Now we will go for equation 2, and then we have this equation 2, that is dabba u by dabba ma, and that is equal to 0, is equal to, now integration 0 to 6, moment will be as it is, va into x plus ma minus 10x square, and now we have this value 1 only, 1 into dx upon di. And now when we will separate out it, we have va integration 0 to 6 x into dx upon ei plus ma integration 0 to 6 1 into dx upon ei, and that is equal to integration 0 to 6 10x square dx upon ei. And then if we will solve this, then we will get it as integration x. So same whatever we have for ma over here. So in ma we have uh, x into dx 0 to 6. Same way here we have 18 va. Now we have, this will be integration 1 0 comma 6. So it will directly come 6. So we have 6 ma, and that is equal to, now integration 10, we have x square comma 0 comma 6, and it comes 720. And this is equation 2. And just we have to go with these two equations. That is our question, that prepare the equations for the redundants. So we have, this is equation 1, and then we have this equation 2. And if we will solve these two equations, then we are going to get value of va and value of ma. So likewise, we have to solve the problems which are from fixed beam. So we will, today we will stop here only. So remaining problems we will see in the next lecture. So thank you.